Students, we'll be dealing with physics chapter ma. So myself Rajeshwari madam, I'll deal physics for you. Okay. So in your intermediate first year, first chapter is physical world ma. That is totally deleted because of COVID-19 situation this year. So 30% of the syllabus has been deleted ma. So first unit is deleted. So as we proceed further, I'll be telling what lessons are deleted. Now first chapter physical world has been deleted. So that's why we are starting with second chapter, units and dimensions, units and measurements. Okay. So let us start our second chapter, units and measurements. Yes. What do you mean by measurement? Measurement means here, if you take measurement means it is the magnitude of physical quantity, magnitude of a physical quantity. The magnitude of a physical quantity is known as measurement. Okay. So what is that magnitude? Magnitude means nothing but the numerical value. Suppose if I am taking length. If I am taking length means how will you measure length? We will measure in either meters or kilometers. Okay. Suppose if I have taken 1 meter and 5 kilometers. Okay. So this 1 value and 5 value, that is nothing but your magnitude. Okay. So 1 means magnitude, that numerical value, how much meters is there, how many kgs is there, so that will give you the magnitude. Okay. So measurement means what? Magnitude of a physical quantity is known as measurement. So in that way we are measuring. Suppose I want to measure mass. I want to buy some vegetables. So if I want to buy some vegetables means in which unit will measure? Will measure in either grams or kilograms. Suppose I have taken 500 grams and 2 kgs. So what is the magnitude here? 500 is the magnitude because it is the numerical value and 2 is the magnitude of the kilograms. So here what are these ones? These grams and kilograms are nothing but your units. So from this, how can we define units? Okay, so the measurement of any physical quantity. The measurement of any physical quantity. The measurement of any physical quantity is known as unit. What is the physical quantity? Length, mass, time, okay, all temperature, all these are known as the physical quantities. That means how we are measuring length in meters, kilometers. So that means this meter is nothing but the unit. Okay, how many meters are there? That numerical value will give you the magnitude. Okay, so that is the measurement and unit definition. Okay, now let us see what are the your previous lower classes measurement units we have studied in your lower class. Okay, so in your lower class you might have studied about CGS system. There are some 3 types of systems. Okay, so CGS system, MKS system and FPS system. Okay, in your lower class, in your 8th, 9th, 10th, you have studied about these systems. What is this CGS system? CGS means centimeter, C means centimeter, G means grams, S means second. Okay, MKS system means M means meter, M means meter, K means kilogram, K means kilogram, S means seconds. Then FPS, F means foot, P means pound and time, S means second. Okay. So what is this centimeter, meter and foot? These are used for measuring length. Then grams, these are used for measuring the mass. Seconds, we are using for measuring which physical quantity? Time. Okay, so like this you have studied some of the systems in your lower class. CGS means centimeter, grams, seconds. MKS means meter, kilograms and seconds. FPS means foot, pound and second. So these are the systems you have studied in your lower classes. Now let us see some of the physical quantities which you have studied in your lower classes. Okay, so let us see about those physical quantities. Yes, some of the physical quantities you have studied, that is here length you are measuring in CGS system. What are the units? We will see CGS system units and MKS system units for length, okay, for mass. So these are your physical quantities. Physical quantities. Okay, so length in CGS system we are measuring in centimeters. Then for length in MK system we are measuring in meters. Then mass in CGS system we are measuring in grams, and in MK system we are measuring in grams. CGS system and MK system we are measuring in kilograms. Then time. How we are measuring time? Time is always measured in seconds, ma. Time is always measured in seconds. Okay. So these are some of the physical quantities. And how to measure the temperature? Temperature is always measured in Kelvin. Whether it may be CGS system or MK system, we are measuring in kelvins. Okay, and here there is one more physical quantity, that is light intensity or luminous intensity. Luminous intensity or light intensity. How we are measuring the light? Okay, light we are measuring in candela. Light, both the systems we are measuring in candela. Okay, so these are some of the physical quantities you have learnt in your lower classes. Okay, now let us see what are the actual measurements we are going to study. We are going to study in your first year. Okay, so here first we will be learning about how to measure the length. How to measure the length? So measurement of length. Measurement of length. How to measure the length? So here we are having two types of measurements of length. How to measure larger distances and how to measure the smaller distances. Length means nothing but the distance. Okay. So how to measure the large distance and how to measure the smaller distance? Let us see. So first topic under this measurement of length is measurement of larger distances. Larger distances measurement. How we are measuring larger distances measurement? So mostly larger distances we are measuring by one of the method, that is called as parallax method. Parallax method. Okay. So now let us study what is the parallax method. Parallax method. So this method is very famous for measuring the distances between the sun and the earth, stars and the earth, sun and the stars. So like that means what all bodies are present in our universe, they are very far from each other. They are the large huge bodies. So how to measure the distance between the sun and the earth? How to measure the distance between the star and the earth? So that can be measured by the parallax method. Okay. So here it is used for the measuring the distances distances between sun and earth and also stars. So these distances can be measured easily by the parallax method. So now let us study how to measure that. What is the process involved to measure the distance between the sun and the earth or the star. Okay. So suppose here I am considering a sun. Consider sun. I am pointing that mark as S. Okay. S means sun. Okay. Take here I am taking one more point A. Okay. So how the earth is revolving around the sun in an elliptical orbit? Earth will be revolving around the sun in an elliptical orbit. Okay. Let us consider this point as B. Okay. So both A and B are the earth only. Okay. So A here I am taking as earth. Okay. So here what I am doing, if earth is at point A, consider one of the star as F. I am taking one of the star as F here, one point. Okay. So the distance between the star I am drawing as a line, imaginary line. Okay. So here one more star is there, N. One more star is N. Okay. And so the distance between these two is the earth, and draw a line between that two. Okay. Then see here, the angle between this N star and F star when it is forming with the earth is, let us consider this angle as theta 1. Let us consider this angle as theta 1. Okay. Then if this earth is coming to the position at B, the same earth, B is also earth only, but earth is continuously revolving around the sun in an elliptical orbit. When the earth is revolving, during that revolution, when its position is changing from A to B, then here the star appears to for the earth in this manner. Okay. So the distance between the star F and B is, draw a straight line. Okay. Imaginary line. Then here N star also you draw a straight line like this. Okay. Then the angle between this star F and N star which is making with the earth, let us consider this angle as theta 2. Once again I repeat, for parallax method, how I am measuring the distance between the sun, earth and the stars. I am considering a point S. That point S is nothing but our sun. Okay. A is the earth. A is revolving around the sun in an elliptical orbit. Okay. So let us consider one star F at a point F. Okay. Then the distance between F and A, you draw a imaginary line. Okay. Consider one more star N. Okay. Draw the imaginary line to the A. Okay. So the angle made by these two stars with the earth, let us consider that angle as theta 1. Okay. Then now at B point, the angle made by the F star and the N star, let that angle be theta 2. Okay. Then here if I am drawing a midpoint of this N to the sun. Okay. So this is what, this is the diameter of the elliptical orbit. How earth is revolving around the sun. Till here it is the radius. If it is changing its position from A to B, means from the sun to the B, it will become another radius. Both the radii will become the diameter. So draw that imaginary line for the diameter. Then see here, if I am taking the midpoint of this N star, then here it will be another angle and here one more angle. So what are these angles? Let us see. See here, this this line AF and SN. These two lines are two parallel lines. When two parallel lines are there, means how we are getting like this, two parallel lines, and here is the midline. Okay, AN is the middle line. Okay, so here is the angle theta, means this another angle will be same theta only. That means the interior opposite angles are equal. So can I write this theta 1 here? Yes. So we can write this as theta 1 because this is interior opposite angles are equal. Then if you take NS and FB, these two are also parallel lines. Then FBN is theta 2, means this is another opposite angle for theta 2 now. So these two angles will be equal, means I can write theta 2 here. Okay, so this is about your diagram. Now let us derive that equation. Okay. So see here, here suppose F is the, suppose A is a earth revolving, revolves around S. S means sun. Okay. Then what is the angle FAN? FAN, angle FAN is equal to what? Angle FAN is what? Theta 1, no? Write down theta 1. Okay. Then next, if this FAN is theta 1 means ANS, angle ANS is also theta 1. Why? Because these two angles are interior opposite angles of two parallel lines. So that's why, because these two are interior opposite angles means they are equal. Okay. So here we can also write angle ANS, is equal to theta 1. Okay. Then next, if you take angle FBN, so angle FBN, what is this FBN? Theta 2. Let us write that one. Angle FBN is equal to theta 2. Okay. Then here angle FBN is theta 2 means then angle BNS will also be theta 2 because these two angles are opposite interior angles. So angle BNS is also theta 2. Then angle BNS is also theta 2. Okay. Then these two angles is the angle made by the arc of the earth and the sun. Okay. So this is the angle of the arc. Okay. So that means angle is equal to arc of the earth made by the sun and radius. So what is the angle? Total angle is equal to theta 1 plus theta 2. So total angle is equal to theta 1 plus theta 2 is equal to, what is the arc here? Arc means nothing but the total diameter. Okay. So total diameter means from A to B. So AB is your arc. Okay. And what is the radius here? Okay. Radius here is AN. Okay. So that means if you consider this total circle, AN will become the radius. So radius here is AN. Okay. So then next here, if I take AN this side, AN is equal to what? Theta 1, theta 2 comes to this side now. So AB by theta 1 plus theta 2. AB by theta 1 plus theta 2. So what is this AB? AB is equal to, AB is total 1 astronomical unit. But AB is equal to 1 astronomical unit, AU. 1 astronomical unit is equal to 1.5 into, so 1 astronomical unit value, it is a constant value, that means it is the distance between the sun and the earth. The total distance between the sun and the earth is known as 1 astronomical unit, and that 1 astronomical unit is, what is the value means 1.5 into 10 power 11 meters. 1.5 into 10 power 11 meters. Substitute this AB, 1 astronomical unit is equal to 1.5 into 10 power 11 here in the place of AB. So AN is equal to 1.5 into 10 power 11 by theta 1 plus theta 2. Okay, so this is our distance. So AN is what? The distance between the sun and the earth, the radius. Okay, so if we know the angles theta 1 and theta 2, we can easily find out the distance between the earth and the sun. Okay, so that is the parallax method. Once again I repeat, if we consider sun at this point and I am taking earth at a point A, then if it is revolving around the sun in an elliptical orbit means, then one more point we are taking as B. So with respect to A, what is the angle we are taking? Suppose consider a star F. From F, what is the angle made by this A to another star is theta 1. Okay, then same n star, and if the earth is changing its position to B means what is the angle made by this n star and f star with the earth is theta 2. So if these two lines are parallel means these two opposite interior angles will be equal. So if NAF, so that means FAN, angle FAN is equal to theta 1 means angle ANS also will be theta 1 because these two are opposite angles. See here, angle ANS is also equal to theta 1. Then what is angle FBN? Angle FBN is theta 2. Then here angle BNS also will be theta 2. Okay, why? Because these two angles are opposite interior angles, na? That's why angle BNS is equal to theta 2. Okay, so what is the angle means? Angle is equal to arc by radius. So sum of the two angles is theta 1 plus theta 2. Arc is nothing but the total diameter of the elliptical orbit. So AB by AN. So that is the radius of the total circle. That means the distance between the sun and the earth. Okay, so that is AN. Then if you bring this AN to this side means it becomes theta 1 and theta 2 comes to this side means it becomes like this. AN is equal to AB by theta 1 plus theta 2. Then AB is nothing but AB total is nothing but equal to 1 astronomical unit. Astronomical unit that is represented by AU. So 1 astronomical unit value is always 1.5 into 10 power 11 meters. Okay, so 1.5 into 10 power 11 meters. So substitute this value in place of AB. So I am substituting AN is equal to 1.5 into 10 power 11 meters by theta 1 plus theta 2. If you know these angles means then easily we can calculate what is the distance between the earth and the sun. Okay ma, so this is your parallax method.